Hey everyone! So in this video, let's take a look at how would you find the volume of a parellepiped. I love that word. What's a parellepiped? It's basically just a parallelogram, which is now a three-dimensional figure. Okay? And I'm not going to try and draw it because I'm an awful artist. But we can just use what's given here and show that it's pretty easy to find the volume of a parallelepiped. So how would you go about doing it? Well, it says the volume, right, of a parallelepiped is just equal to the magnitude of the scalar triple product. What does that mean? It means you take, if you have some vectors A, B, and C, if we take A vector and we dot it with B cross C, that'll give us the volume of this parallelepiped. Well, what does that mean? Well, we're given that this parallelepiped has these adjacent sides, PQ, PR, and PS, which are vectors. This little vector hat means these are vectors. Okay, but what are those vectors? We're given 4 points where we know what P, Q, R, and S are, right? These are all X, Y, and Z coordinates, so they're all in three-dimensional space. But what are the P, Q, PR, and PS? Well, it's just the distance from PQ is from P to Q. So we can let A vector, because we want this A, B, and C. We can let A vector equal what? Equal the distance from P to Q. So you just take your Q coordinates, you subtract off your P, and that would be the distance from P to Q. So your X, and for a vector, we normally have these pointed brackets. That just means it's a vector now instead of just a point, right? So it's the distance from P to Q would be, your X would be -1 minus 3. So that's -4. Then your Y is 2 minus 0. So that's 2. And then your Z is what? Is 5 minus 1. So 4. Okay, so now we have an A vector. How about we let B vector equal PR. Equal PR. And I should have said here, A vector is equal to what? Is equal to PQ. Okay, A vector this is PQ, which is given to us, which is equal to the distance from P to Q. So B is PR. PR is just the distance from P to R. So what's that? So here's P, here's R. Just subtract off your X coordinates. You got 5 minus 3. Here's 2. 1 minus 0, 1. Minus 1 minus 1, minus 2. All right? So there's our A vector, our B vector. How about we let C vector equal PS, right? Equal PS. Okay. And what is PS? The distance from P to S. So we take S and subtract P. So 0 minus 3 is a minus 3. 4 minus 0 is 4. And 2 minus 1 is 1. There we go. There's A and our B and our C. So now we're saying the volume is equal to A vector dotted with B cross C. So we got to find B cross C first, right? That'll give us, the cross product gives us a vector, and then when we dot product A with that new vector, that'll give us a scalar, and that scalar is our volume. That's it. So, okay. So how do we find the cross product of B cross C? You just take the determinant, which we can write like this. You write a line here, and then you write IJK, okay? Just write IJK, and then what? We write our B vector on the next line. That's B cross C. So what is B? Well, B was 2, 1, -2. So just the components of B, which is 2, 1, -2, 2, 1, -2, and then the components of C, right? Because B cross C, and C was negative 3, 4, 1. So negative 3, smudge there, negative 3, 4, 1. Okay? Now, to find the determinant, well, we're just going to do a 3 by 3 here. Let's start with our I, and you cross out the column and row that have I. So just write I, and then another line. And what's left? When we cross out the column and row, we just have 1, negative 2, 4, 1. So 1, negative 2, 4, 1. And it's always going to be subtracted j. It's going to be I minus j. Now you're going to cross out the column and row with j. And that'll leave the 2, negative 2, negative 3, 1. So 2, negative 2, negative 3, 1. And then plus k. And you should, same way, cover up your column and row. And that'll leave the minor, which is 2, 1, negative 3, 4. So 2, 1, negative 3, 4. Okay. And now, once you have a 2 by 2 matrix, all you do is to find the determinant, you take the product of this diagonal minus the product of this diagonal. So here is 1 minus a minus 8, right? This is 1 times 1, which is 1, and then minus 4 times minus 2. So that's 1 minus a minus 8, which is 1 plus 8, which is 9. So it's 9 times I, so it's just 9I. And then it's minus, well, what? Same way, 1 times 2 is 2, minus negative 3 times negative 2. Well, this is a positive 6. So this is 2 minus 6, which is minus 6. But it's a minus sign out front. So it's minus a minus 6. You see that? 1 times 2 is 2, minus negative 3 times negative 2. So this is, right, this is 1 times, 1 minus, because you always subtract. It's this minus this. This product minus this product. So it's 2 minus a positive 6. So that's a 2, not a 1. That's a 2, right? That's a 2 minus positive 6. So that's 2 minus 6, which is minus 4, right? But it's a minus sign out front. So it's minus a minus 4 or plus 4, right? So it's minus a minus 4. So it's plus 4 times j. So it's plus 4j. And then your last, for your k, it's plus k. So it's 4 times 2, which is 8, minus a minus 3, right? 4 times 2 is 8, minus 3 times 1 is minus 3. So that's 8 minus, it's always this minus this. This product minus this product. So it's 8 minus a minus 3, or 8 plus 3, which is 11. So it's plus 11k. And then that's it. And then you can take this, and then to put it back into this vector notation from your ijk, you just take your coefficients of your I, j, and k. So 9, 4, and 11. And then we want to dot product, right? A dot B cross C. So A is negative 4, 2, 4. So it's A's over here, negative 4, 2, and 4 dot product with this. And the dot product, you just take negative 4 times 9 is negative 36. And then add 4 times 2, which is 8. And then add 4 times 11, which is what? 44. And if you add negative 36 plus 8 plus 44, what you get is 16. 16. That's it. So the 16 cubic units is the volume of the parallelepiped. Cool, huh? See you soon.